A crane hook is in equilibrium under the action of three forces as shown in the diagram. Calculate T1 and T2. Okay, I have a horizontal bar connected with two ropes to the hook here. Tension of the hook is 3.8 kilonewtons and tensions of the two ropes right and left are T1 and T2 respectively with given angles. I must decompose T1 and T2 at first and then go through conditions of equilibrium in horizontal and vertical directions. So sigma fx is equal to 0, condition of equilibrium on horizontal axis, and then sigma fy is equal to 0, condition of equilibrium on vertical axis, and by solving the two equations together I will find T1 and T2. Okay, here let's start by decomposing T1 and T2 on vertical direction. So this is the vertical component of T1, which is T1 cosine of 60 degrees. Likewise, this is T2 cosine of 30 degrees, and here the two downward components must cancel 3.8 kilonewtons. Why? Because sigma fy is equal to 0. I write the condition of equilibrium on vertical direction. T1 cosine of 60 degrees plus T2 cosine of 30 degrees is equal to 3.8. And as the right side of this equation has the unit of kilonewtons, likewise I will have T1 and T2 in kilonewtons accordingly. Okay, I should continue by decomposing T1 and T2 on horizontal axis. Here, the angle between T1 and the horizon will be 30 degrees because the sum of 30 degrees and 60 degrees will give you a right angle here. So this is T1 cosine of 30 degrees, and also you can write T1 sine of 60 degrees. It's up to you. Here I will have 60 degrees the angle between T2 and horizon, and then decomposing will give you T2 cosine of 60 degrees here. The right and the left components must cancel each other because I know that sigma fx again must be equal to 0. Okay, here I write this condition again. Cosine of 30 degrees is equal to a square root of 3 over 2, and cosine of 60 degrees is a half. So if I substitute the values, I will find T1 square root of 3 is equal to T2. Here, as you see, cosine of 60 degrees is again a half, cosine of 30 degrees is square root of 3 over 2, and then T2 is this package, so it could be substituted here. If I substitute the values, we will have something like this. This package will give you 3 halves, and here I have 1 half, so the sum of 1 half and 3 halves will give you 4 halves, and then it is equal to 2. So 2 times T1 is equal to 3.8. So I will have T1 for 1.9 kilonewtons here. And if I substitute T1 here, I will find T2 to be 1.9 times square root of 3 kilonewtons.